So as we saw in the last video, Beautiful Soup contains all of these methods for finding specific tags where we believe our data live. So a lot of the work of web scraping, after downloading the HTML and parsing it, is just searching through it, figuring out where the data we need live, and then how to extract it, okay? And then we use those tools to both search and extract. Once we have done all that, once we've extracted these lists, we need to build a clean data frame if we're going to do any subsequent analysis. So in order to do that, we have to take our data, whether it lives in an attribute or it lives in a navigable string, and isolate it. We don't want to bring along any additional HTML tag information when we convert it to a data frame. And so a very, very useful tool for this is called a list comprehension. A list comprehension is a kind of loop in Python. It's a very clever, condensed kind of loop that exists entirely within a list. And here's the syntax. We're going to create a new list by looping across the elements of an old list, an existing list, okay? For each item of that list, and this word item, we're going to replace with the letter, and that letter is going to denote one item of old list, right? So for every single item in old list, we're going to run the same expression and then save the output in new list, okay? Just to go over this one more time, we're going to create our new list by iteratively performing operations on the elements of an existing list. That's the old list, right? And then item represents one item of that list. And then expression is the Python code we're going to perform on every item of that list. Okay? And then the last bit of this, if condition, that sets a filter. It's optional, and we don't have to do it. But it sets a filter so that only certain elements of the old list are transformed and placed into the new list. Okay, that's a lot of words on the screen at the moment, and it's pretty dense. It's going to make more sense if I show you some examples. So first, this is how, in the Jupyter Notebook for this module, I've extracted the artists, okay? So I've created a list called artist list. And artist list I obtained by using find all. I used find all on span and artist. And it gave me all the HTML tags that contained the artist, okay? Now the artist, their names were actually in the navigable strings. So in order to extract the navigable string, I have to type .string, okay? A is my token. It is what's going to stand in for every single element of artist list, right? So first, this loop looks at the tag for these artists, Kurangbin. I don't know how to pronounce that, but Kurangbin and Leon Bridges. Leon Bridges is amazing. And so it looked at that tag, and then it extracted the string, and it put it into a new list called artists, okay? And then it went through all of these other artists. Okay, after running the comprehension loops, then you can build your data frame that contains all of your clean data. And the best way to do this is to specify a dictionary and then pass that dictionary to pandas.dataframe, okay? So using the method that I just showed you on the previous slide, I extracted the artist, I extracted the time of day in which each song was played on the radio, I extracted the song titles, and I extracted the album name. And I put them together in a dictionary with exactly this syntax. Note, this is how I'm going to name a column, right? So it says time down here. And this should not have quotes because this is an existing list in Python's memory, right, that I've already created. Okay, so I create my dictionary, and then I pass it to pandas.dataframe. I give it a name, and then this is what it looks like. And here we have it. This is data that I pulled from a website. I cleaned it, and I put it into a data frame. And now there are many things I can do with it now that I have it in a pandas data frame. Okay, the last topic is a spider. Now, a spider is a web scraper that follows links automatically when it finds them, navigates to those pages, and scrapes data off of those as well. It's a spider because it crawls through all these different web pages that are all connected. So to build a spider, there are 3 steps. First, you need to find in your HTML the URLs for additional web pages that contain relevant data. And you're going to store those URLs in a list. And I'm going to show you an example of this in just a minute. 2, you're going to put all of the code to scrape one page into a single function that takes in the URL that you're trying to scrape and spits out a clean data frame. Okay? And then third, you're going to loop over the URLs that you found in step 1, and you're going to apply the function that you built in step 2 to each one of those URLs. And then inside that loop, you're going to append all those data frames together. And in that way, you're going to have a data frame that collects all the data, not just from one page, but from all the pages that that page linked to. Okay? So here's an example of step 1. For the example in our Jupyter Notebook, I used this code. Now, this doesn't have to make sense right away, but let me just talk about what I'm doing in each line. So on the first line, I'm finding all of the links that had the div and recent playlist, the div tag and the recent playlist class. Okay, it turns out just by Control F and looking at the HTML, this is where the links live that I want to crawl with my spider. Okay, so I find it, and then from that tag, I extract all of the A tags. It just so happens in that code that I extracted, which I called recent, the URLs live in the A tags. Then I'm going to loop over those A tags, right? So this is another comprehension list. I'm going to loop over those. And for each element, which I'm calling PL, I'm going to pull out href, which is a hyperlink. But only under this condition. So this is searching for the string /PL in the URL. The reason for that is some of the URLs went to playlists and some of the URLs went to information about the DJ. So I didn't want it to be /DJ. I wanted it to be /PL. So this line of code gives me a logical condition that's true if it finds /PL in the URL, and I only want to keep those. So after applying that, I've got this list of URLs. Now, these don't look like full URLs. The reason is I have to put the base of the URL on it as well. In this case, it would be https://spinitron.com and then /WNRN/PL. Because each one of them is going to have the same beginning, I don't have to include that yet. I can include that later when I use my function. That's step 1, getting the URLs. Step 2, putting all of the code to scrape one page into a single function. So, to create a function in Python, use the def syntax. Okay? Now, this is a whole lot of code. I generally don't like to put this much code on one slide, but I'll go over it. I think it's going to make sense. So first def, this means I'm going to create a function. And then you give your function a name. So the function I'm creating is called WNRN spider. And then parentheses, and then inside the parentheses are going to be the arguments that a user needs to input in order to make this function work. So I'm saying, in order for this function to work, I have to provide it a URL. Okay? And then everywhere in the code below where it says URL, it's going to be whatever the user input. Okay, and then it's going over everything that we've already done. So first, it defines a user agent string, and then it gets the HTML from that URL. Then it uses Beautiful Soup to parse the output as HTML. Then, now that I have the HTML code, I'm going to use the find all method to extract the tags that contain my artists, the tags that contain my songs, the tags that contain the albums, and the tags that contain the times when each song was played. So these are the lists that have the HTML syntax still in them. These are the 4 comprehension lists that go through it and just extract the navigable string so that I no longer have the HTML code. And then I put them all into a dictionary, and then I create my data frame, and I return that data frame. Return in a function specifies what should be the output of the function. So in this function, WNRN spider, a URL goes in, a clean data frame comes out. So that's step 2, is to create a function that does all of this work for one page. And then step 3 is to loop over the URLs, apply the function that we just made to each one, and then append these data frames together. And so the code to do that looks like this. Okay, I'm going to start by creating a Python variable called WNRN total playlist, and it's going to be equal to the data frame that I created from that front page on Spinatron. Then I'm going to loop. So for W in WNRN URL. Now WNRN URL was the list of the URLs that I'm trying to loop through. So I'm going to go across each one of those URLs, and I'm going to designate each URL as W. Then I apply my WNRN spider function, which is going to put together the beginning of that URL with the ending of that URL contained in W. So I pass it a complete URL, and then the output is a clean data frame, which I'm saving as a variable called more data. Finally, I'm going to take this WNRN total playlist that I defined on the first line, and I'm going to append it to what had previously existed as a WNRN total playlist, appending to it more data. And appending is going to give me more rows. And then when I see the total playlist, I can see that I have all of the playlists going back through yesterday, all put together in one data set.